Hello, everyone. Good morning. Hope you're enjoying React Day so far. You're having a good day. I'm Sreetam Das. I am a senior front-end engineer at Remote, and I primarily work with the growth and marketing team. Yes, my company is literally called Remote. I also love mechanical keyboards. So if you're on Twitter and you've seen mechanical keyboards on your timeline, I'm sorry, but not really. I also love CSGO. So if that's something that interests you, please hit me up after the talk. Anyway, on to my talk. Today, I'll be talking about building a. Wait, sorry, go back. Let's do this again. Today, I'll be talking about perfect dark mode. Thanks. Before we begin, a huge shout out to Josh. His work on the exploration of color themes in Gatsby was my inspiration for doing it in Next.js. His blog post is called The Quest for the Perfect Dark Mode, and I highly recommend checking it out. All right, so let's think about what happens when we load up a website with support for dark mode, which we have visited before, and saved our preference with the dark mode enabled. Answer the question, what really is the perfect dark mode? Imagine this. You load up a page and then flashbang. Hello to three of you who understood that reference because they play CSGO. You see a completely white screen, completely disregarding your saved preference. The flash, that dreaded flicker of light mode, completely blinding you for that one second. So, why does this happen? Well, kind of because of React. Eh, that's not great. Well, why does this happen? Let's go back to our basics and think about what happens when we visit a page. Our HTML gets loaded first, which in turn then loads our JavaScript and CSS, and we use our link and script tags to do this. With React being client-side rendered, this JavaScript first needs to be parsed, and only after that are components shown. Until then, unless specified, it's a blank page. To kind of show you what I'm talking about, let's look at what the Create React app entry point looks like. If you've opened your public folder, this is a file inside it called index.html. In particular, you'll see just a single div with the ID root, wherein we basically load up our entire React app. So let's go back. Why is the body, why is the page here completely white? Well, thing is, by default, a web page has a transparent background color. Well, wait, I hear you say in the background, what if we could just check if a user prefers dark mode using media queries? Well, you're smart. We'll get to that. But also, in this particular example, you would have to use inline CSS. And sadly, inline CSS does not support media queries. Remember, we don't want to make the mistake of showing dark mode to a user if someone prefers light mode instead. So we can't even find out with just inline CSS if the user even prefers dark mode. But we're really getting ahead of ourselves. Let's start with a very basic example. Here we have a very basic toggle input, a simple input, and then some text. Let's add some React state and an on-change handler to it, as well as some styles. And this is what it would look like. Cool, that works out. Nice. If you go back to our example, if we want to make some more adjustments to the rest of the page, you would extend these styles by adding some CSS class and then also some appropriate CSS. Okay, now we can actually get started with what we want to do here. So let's note down what we're trying to accomplish. Here's what we want. If the user has visited our site before, we use the saved preference. If they haven't visited our site before, or they haven't saved their preference, we check for a system-wide preference. If that still doesn't give us anything, then we default to a light mode. But don't forget, all of this needs to run before our page is rendered or shown to the user. And we also want to allow the user to actually toggle the dark mode and save the preference for the next time they visit us. Okay, so what's next? How do we actually first store and retrieve the user preference? Well, this one's pretty straightforward. Local storage is simple and it's great. I'm sure you might have used it before as well. Here is what setting and getting the preference would look like. That setting, and then here's how you would retrieve it. Great. Now, the next step is how one would find out what the system-wide preference is. Here, we can use the prefers color scheme media feature, which detects if the user has requested a light or dark color theme. And we can use the match media method in order to run our media query. And that's what it kind of looks like. You just run the match media method along with that query, and it gives us back if that query matches or not. Sweet. Great stuff. Let's add these to our example app. This is what we had previously. We'll go ahead and add some functions to set, to store, and get the preference when we change things. Um, and then let's also go ahead and retrieve the system-wide preference. Next, we'll also make sure that we are computing these values when a component is being mounted or loaded. And then we also add a check if we, like we mentioned earlier, if we are not able to figure out if the user has some previous set preference, then we figure out the system-wide preference. And then just to make sure we are actually saving this preference when the user toggles it, we add this particular block. Phew. All right, that was a bunch. Let's recap a little bit. Here's what we've done so far. We retrieve the user set preference if it exists on mount. If not, we get the system-wide preference. We default to light mode, and whenever the user toggles, we save this particular preference. But all of this runs after the initial loading. So how do we run all of these checks before the user actually sees that particular flash? Remember, the problem is still that React is client-side rendered. Well, would adding Next.js magically solve this entire issue? Do we need to use something else instead? Client-side rendering kind of sucks. Well, actually, what if I told you there was a way to run some code before showing the page's actual contents? Enter our humble script tag. Take a look at this particular code snippet. By default, our script tags are actually blocking in nature. What that means is when you try to run this particular code snippet, well, let me actually just show you. Sec. There we go. We don't see anything. And we only see the actual HTML after that alert has been passed. Let me refresh that once more. No content until the alert is actually discarded. Sweet. Wait, so why did that happen? What's happening here? Well, before the browser can actually render a page, it has to build the entire DOM tree by parsing the HTML markup. During this process, wherever the parser encounters a script, it has to stop and execute it before it can continue parsing the HTML. In case of an external script, the parser is also forced to first wait for the resource to actually download. This is actually why this is why we have the async and defer attributes, because they allow us to basically not block the page from completely loading. So the next question is, where do we add this particular script? Because we really want to make sure that it is the first thing that is encountered inside the body tag, so that it blocks painting the rest of our content. If you're using Next.js, it provides us with the document that you can easily access. Let's see what that would look like. So if you've opened up your document, this is what you will see. And let's kind of go ahead and add things. Why? So I hear you say, you want me to add things, but it says it's dangerous. Well, usually setting HTML from code is risky. It's easy to kind of expose your users to cross-site scripting attacks. React actually sanitizes these contents before rendering it by default. But also, it provides us with a way to override this behavior using the dangerously set inner HTML attribute, reminding us at the same time that it is indeed dangerous. In our particular use case, though, we do want to inject and run a script. All right, so we are making some progress. Now we know that we need to run our script and we want to run it as quickly as possible when the page loads up. So, how do we do that? Enter immediately invoked function expressions, or IFEs for short. Wait, so what is an IFE? Well, it's basically a function that is executed as soon as it is defined. We want to kind of do this because we want to, one, run the function as soon as it is defined, like I mentioned. And at the same time, it also has the added benefit of avoiding polluting the entire global namespace. And in our use case, we have no use for our logic. We have no use for our logic after it's been run once. So let's see what that would look like. You can note here the parentheses that we have at the starting and the end, and how we have another set of parentheses right at the end that makes sure that the function is run as soon as it is defined. And just in this particular example, if you try to console log the name variable outside of the IFE, you would get an error because it's not available outside. Okay, so let's add what we have so far to our Next.js document. So first, we'll add a function to compute and set the initial color mode. Let's start working on that. First, we'll get the saved preference if it exists. Then we'll try to get the system-wide preference. And then because our function needs to be a string, we add this particular code snippet. But we still need to figure out how to actually use this preference. That's what we'll see in the next step. Sweet. So let's see what we have so far. We can correctly retrieve the user's prior preference. If they don't have one, we can also see and retrieve their system-wide preference. And all of this happens before the user actually sees the page. So no more white flash. Right. Now, our final hurdle is how to pass this onto our page. We need to transfer this piece of information from a pure JS script that we have, which is being run before the page has been fully parsed, and then use it in our page somehow. Well, there are a couple of ways that we can do this. Maybe we could use CSS classes for different themes and then switch them programmatically. Maybe we could use some React state, maybe even pass a class as a template literal. Perhaps there's even a solution with certain CSS and JS libraries. Well, we don't need to do all of that because all these other solutions also do require some additional setup. Well, enter CSS variables. So basically, these are entities which can reuse specific values throughout the HTML document. They can also be overloaded, so you can redefine them in different places. And the best part is that they are reactive. So resetting their value applies the changes instantly to the entire document. So you don't need to listen to the changes in a use effect anymore. So let's see what that would look like. In this particular example, you see the dot root, you see colon root. So this is a pseudo class, which matches the root element which represents the entire document. So in our particular case, that would be HTML. And this is how you would use that CSS variable. If you see, there's also a value after the comma, which is a fallback value. And this is how we would go ahead and actually set these properties as well as retrieve their values inside of JavaScript. So we're already seeing a change of setting values, setting CSS variables, and then being able to set them as well as get them inside of our JavaScript. CSS variables are great, again, just to repeat, because they are reactive. They remain live throughout the lifetime of the page, and updating them updates the HTML that references them wherever they're used instantly. And they can be updated with just JavaScript. You can even combine them with HTML attributes. What that means is you can assign different values to CSS variables depending on the different attribute that you define them inside. Here is what that would look like. So you have these initial values of all these different variables. And then for dark mode, we can also redefine them inside the data theme attribute. And this is just a little Easter egg. And we can set and remove these attributes pretty easily with JavaScript too. So whenever we are toggling our dark mode preference, we want to make sure that there are no clashes with our CSS variable declarations. This is what, and here's how you would actually set and change the attribute as well. So whenever the user toggles dark mode, we can add the data theme attribute, and then wherever they fall back to light mode, we can remove this particular attribute. Sweet. We can now pass on the computer dark mode preference from our blocking script to our document. Okay, so before we put everything together, let's recap everything once more. So what do we have? As soon as the page is loaded, we wanted to inject and run a script, which we're now able to do with Next.js's document, as well as ifs. We are able to check for a user's safe preference from their previous visit using local storage. We are also able to check for the system-wide preference using a CSS media query. And we're also able to fall back to a light theme. On the first load, even if the user has preference for the non-default theme, we are still able to account for this. By passing the preference as a CSS variable, the theme can be toggled and the preference can be saved for future visits. What we want to make sure, sorry, what we want to make sure is that we never have that flash, that flicker of white light. And we always want to show the correct state of our toggle. And in case that's necessary, we defer rendering the toggle if the correct state is unknown, which would be on mount. Awesome. So let's put everything together. So this is where we basically left off. So first, we add this particular code snippet in order to set the property that we detected. Then we set the particular attribute for the theme. Let's go ahead and then sprinkle in some of our CSS. We'll be keeping it simple for our particular example. We'll be adding something for just the default theme, and then something for the dark theme as well. And as an example, here is how we would use it in our particular page. So let's go back to our example and add all these. So first of all, normally we would try to detect all these values inside of our component itself. But like we discussed earlier, all of that would happen normally after the entire component has been mounted, which results in that flash. So we go ahead and remove all these. Then the next thing that we add is simply retrieving that value that we've set earlier. And then storing the particular preference whenever user changes these. And then to make sure that we're not showing our toggle when the incorrect state is known, we don't show it initially. Amazing. We've done it. No more blinding eyes of users who prefer the dark mode. And it respects the users who actually prefer light mode as well. That's the end of it. If you want to kind of follow up a little more, you can check out Josh's post, which is also linked. If you're interested about finding out what I used for this particular talk, I used MDX Tech as well as CodeSurfer. The theme in the code snippets you saw is my own. It's called Karma. The font I use is called ISFK. These are the particular colors that I used. And for everything else about my setup, you can go to my users page. If you want to try it out, you can check it out live on my website. It's already implemented there. If you want to read the blog post that I wrote about it, you can go to those links as well as the slides. And if you have any questions, you can always hit me up on Twitter. See you in my session. If you want to talk anything about my talk, mechanical keyboards, CSGO, working remotely, your favorite TV show, or literally anything else, or if you just want to come and tell me if you like my talk, I'll see you there. All right. See ya.